Adding and subtracting algebraic fractions. The learning goal is to simplify algebraic expressions that involve algebraic fractions separated by addition or subtraction symbols. You'll know that you've mastered this if you can manipulate algebraic fractions to form a common denominator between two fractions. Also that you can combine two fractions that are added or subtracted, and then simplify a single fraction. The key thing today is that you can only combine fractions with a common denominator if they are added or subtracted. So if the denominators are the same, you simply need to add or subtract the numerators. Though if the denominators are different, we need to multiply one or both of the fractions, top and bottom, so that the denominators match. Let's give it a try. Okay, so to simplify 2a, x over 5 plus x over 5, because the denominators are the same, we simply need to add the numerators. So on the numerator is x plus x all over 5, and so that is 2x over 5. We now also check whether we can simplify any further, and we can't in this instance. B, 4m divided by 7 minus 3m divided by 7. Notice again that both the denominators are the same, and so we simply need to subtract the numerators. So it will be 4m minus 3m over 7. Notice there that we don't actually change the denominator. It's like if we had 3 out of 6 slices of pizza, and we ended up eating 2, then we would only have 1 out of the 6 left. So the denominator does not change. Let's have a look at what happens when the denominators are different. 3a, x over 3 plus x over 2. These two, they're different. And so we need to multiply both top and bottom in order to make them the same. So the first number that both 3 and 2 fit into is 6. And you can get that by just multiplying the two together. 2 times 3 is 6. So if we change both to be out of 6, then we should be able to get it. So x over 3, if we double that, if we times both by 2, that will make the bottom 6. And the top now will be 2x. So it'll be 2x out of 6. Now in the second one, if we times both the top and the bottom by 3, we're going to get 3x over 6. And now that we've done that manipulation, we're back to a similar question to on the previous page, where all we need to do now is just add the numerators. So we're going to get 2x plus 3x on the numerator divided by 6, which is 5x over 6. Part B. 2n divided by 5 minus n over 10. Again, these two are different, so we need to make them the same. In this case, you can see that 5 fits into 10. And so if we just change this first fraction to be out of 10, then we'll get it. So if we multiply by 2 on the top and the bottom, let's do our line of working over here. This will be equal to 4n over 10 minus n over 10. So now both our denominators are the same. So we'll subtract the numerators. 3n minus n over 10. Sorry, 4n minus n over 10, which is going to be equal to 3n over 10. Okay, let's look at 2 more. And you might want to pause this video before I do each step just to see if you can figure out what steps to do. Okay, so in this example on the left here, we've got 7p divided by 4 minus 5p over 6. In order to make the denominator the same, the first number that both 4 and 6 goes into is 12. And so to make this fraction, the first one out of 12, I need to multiply the top and the bottom by 3. To make the second one the same, out of 12, I need to multiply the top and the bottom by 2. So we get 21p over 12 minus 10p over 12. And now we can subtract the numerators, combine the fractions, 21p minus 10p on the numerator, all over 12. And that's equal to 11p over 12. Now to the example on the right hand side, we've got 3x minus 1 over 2x. This time, the denominators have pronumerals on them. The same sort of idea applies. We need to make the denominators the same. So how could I do that? Well, I could make both the bottoms 2x. So if this one's already 2x, if I just multiply x by 2, I get 2x. So if I do 2 times that on the top and the bottom, I will then be able to change that first fraction to have a denominator of 2x. And then it means that I can simply combine the two. They're the same denominator, so I can just subtract the top, 6 minus 1, all over 2x, which is just 5 over 2x. And again, I can't cancel there. Okay. Why don't you pause the video and see if you can complete these two. Okay, let's look at the solutions. In the first one, the denominators are the same, so we can simply add the numerators. So it will be 5a plus a over 6, which is 6a over 6. Notice there's a common factor of 6 on the top and the bottom, so I can actually just cancel those, and I get a. In the example on the right, 3a over 5 plus a over 4, they're different. The first number that they both go into would be 20. So I could change this one, you need a factor of 4, and the one on the right, you need a factor of 5. So that first fraction becomes 12a over 20 plus 5a over 20. Combining those two, you get 17a over 20. check these against how you went. I'm going to do 2 further questions. They're just a little bit more difficult. On the first example here, we've got 2x plus 5 over 6 plus x minus 4 over 3. The philosophy remains the same. We want to make the denominators the same. At the moment, they're different. So, having a look at these denominators, 3 does fit into 6, so I can just double the second one. So, my first line of working, I will just double this one and that. And notice that I've got to, when I'm doubling the numerator, I've got to double both the x and the minus 4. So that next line becomes 2x plus 5 over 6 plus 2 lots of x minus 4 over 6. Now I'm going to expand that second bracket. Now I have the denominators the same. I'm just going to combine the fractions. So on the numerator will be 2x plus 5 plus 2x minus 8 all over 6. I'm now going to collect like terms. Simplify, I'm going to get 4x minus 3 over 6. One on the right hand side, I've got x over 3 minus x plus 1 over 5. The first number that both 3 and 5 go into is 15. So to get from 3 to 15, I'm going to multiply by 5. On the right hand side, I've got to times by 3 on the top and the bottom to get to 15. And so I have 5x over 15 minus 3 lots of x plus 1 over 15. Expand that out again, 3x plus 3 over 15. Now this is where I need to be careful because as I combine these, this minus in the middle here, that needs to apply both to the 3x and the 3 on the numerator of that right hand side fraction. So when I combine it, I actually get 5x minus 3x plus 3 all over 15. Now collecting like terms and simplifying, I've got 5x minus 3x, which is 2x, and minus 3 over 15. And we're done.